Yeah, this is what we are discussing in the last class, ma. The treatment of water, treatment of boiler feed water, external and internal treatment. Okay, here the internal treatment is by conditioning methods. Using the internal treatment, we are going to these conditioning methods like Calagon conditioning, colloidal conditioning, phosphate conditioning. Okay, by using these treatments, we are going to use that. Okay, by these conditioning methods used in the treatment of internal treatment like colloidal conditioning, phosphate conditioning, and carbonate conditioning. Now coming to the water softening by the external treatment. Okay, it is by three methods, ma. One is lime soda process, zeolite process, and ion exchange process. But in our syllabus, we have only ion exchange process. What actually the ion exchange is? What actually the ion exchange is? Here, ion exchange is a process by which ions held on the porous membrane. Okay, ion held on the porous, especially insoluble solid, are exchanged for the ions in the solution. Okay, how we are going to exchange this by using this external treatment is here the ions present on the porous solid are exchanged for the ions in the solution that is brought in contact with it. Okay, by using this ion exchange resin, we are going to exchange the one ion with another ion. Okay, by using this ion exchange resins. What are ion exchange resins? Okay, these are insoluble. Okay, ion exchange resins are insoluble, cross-linked, high molecular weight. Okay, these are high molecular weight compounds. High molecular weight organic polymers. Organic polymers are nothing but resins, ion exchange resins. Okay, insoluble, cross-linked, high molecular weight organic polymers. Okay, with porous structure. Porous means it contains holes. Okay, porous structure, and the functional groups are attached to the chains are responsible for the exchange properties, ion exchange properties. Whatever the functional groups that are present are responsible for the exchange of ions. Here, these are insoluble. These resins are not soluble in the water. These are insoluble, cross-linked, high molecular weight organic polymers with porous structure, and the functional group attached to the chains are responsible for the ion exchange properties. Functional group present on the chains are responsible for the ion exchange properties. Ion exchange properties. Here, coming to the ion exchange resins are classified into two types. Ion exchange resins are of two types. One is cation exchange resin. Cation, positive. Okay, cation, name in the name itself it is there. Okay, till now we have discussed about the resins. What are ion exchange resins? Okay, these resins are of two types. One is cation exchange resin, and anion exchange resin. Cation exchange resin and anion exchange resin. What actually the cation exchange resin? Okay, it is represented with RH plus. Okay, R is the resin, okay, H plus, and anion ROH minus. ROH minus is nothing but anion exchange resin. Okay, it is represented with RH plus in the reactions while doing the reaction in the process. Okay, here we are going to use this RH plus RO minus. We are not going to use this large structures ma. It has this. These are the exchanges ma. Cation exchange resin and anion exchange resin. We'll discuss what the cation exchange resin and what are the anion exchange resins. Coming to the first one, what is cation exchange resin? Okay, it is represented with RH. These cation exchanges are capable of exchanging their H plus ion. Okay, in the cation exchange, it contains RH plus. RH plus. This H plus ions with cations of dissolved salt. Cations of dissolved salt, which comes in their contact. Okay, here these exchanges are capable of exchanging H plus ions. Okay, it helps to this H plus ions are exchanged with the dissolved salts present in the water, which comes in contact. Okay, here these cation exchanges are represented by general formula RH plus. Okay, and they are these are nothing but styrene divinyl benzene copolymers. Okay, cation exchange resins are nothing but here it is made up of styrene. Okay, styrene divinyl benzene copolymers. Styrene divinyl benzene copolymers. It is made up of styrene divinyl benzene copolymers containing the functional groups of acidic functional group or sulfur functional group. Okay, acid functional groups. Okay, this sulfonyl functional groups. Styrene divinyl benzene copolymers containing functional groups like acidic COOH or SO3 sulfur oxide functional groups. Okay, here R is the general structure of the resin. Here what R represents the structure of the resin, and the H is the exchangeable with cation. H is the exchangeable cation. R and H. Okay, cation exchange resins are made up of styrene divinyl benzene copolymers containing functional groups like acidic functional groups are acidic functional groups are sulfur oxide functional groups, SO3H functional groups, SO3H functional groups. Here coming to the anion exchange resin, what actually the anion exchange resins are. Okay, here anion exchange resins are styrene divinyl benzene, same styrene divinyl benzene copolymers containing functional groups of phenyl formaldehyde or amine formaldehyde. Phenyl formaldehyde or amine formaldehyde, which exchanges their OH ion with any anion present in the dissolved salt. Okay, which exchanges the OH minus ions with any anion present in the dissolved salt. Okay, it exchanges the any anion present in the dissolved salts. Okay, this anion exchange resin. Okay, this anion exchange resin is represented with generally ROH. Here also it is represented ROH minus. ROH minus. Okay, R is the general structure ma. R is the general structure of the resin, and OH is the exchangeable anion. Okay, this OH minus is responsible for the exchange of anion. Thus, cations and anions present in the dissolved salts. Cation and anions present in the dissolved salts are exchanged with the cation exchange resin and anion exchange resin. Is whatever the cations and anions present in the dissolved salts. Okay, in the dissolved salts are exchanged with cation exchange resin and anion exchange resin. Okay, this is the structure of cation exchange resin and anion exchange resin. Okay, cation exchange resin. This is the first structure is cation exchange resin. Okay, this is divinyl benzene, styrene divinyl benzene copolymers. Okay, simple structure. You can in the exam, if you can draw this simple structure ma. That is I am writing here. Benzene. Okay, styrene divinyl benzene. Okay, styrene divinyl benzene. Here on benzene CH2. Okay, it is a polymer CH2 and SO3 minus H. This is a polymer. You can represent it in the form of in the bracket and close it and keep the N. Styrene divinyl benzene copolymer. Styrene divinyl benzene copolymer. Here it extends like continuous. It continues its chain. Okay, this is the cation exchange resin. Cation exchange resin. Okay, it contains acidic functional groups are okay sulfur dioxide functional groups. Cation exchange resin. Here coming to the anion exchange resin. Here it is also phenol formaldehyde. Okay, styrene divinyl benzene containing phenyl formaldehyde. Phenyl formaldehyde is the anion exchange resin. Amine formaldehyde is containing functional groups like phenyl formaldehyde or amine formaldehyde, which exchanges their OH minus ions. Okay, that is anions with an anion present in the dissolved salt. This OH minus ions are exchanged with the whatever the anions that are present in the dissolved salt is nothing but anion exchange resin. Okay, here anion is the here R is the general structure of the resin and OH is the exchangeable anion. Here these anions, cations are present in the dissolved salts are exchanged with this exchange resins. Cation exchange resin and anion exchange resin. This is the structure of cation exchange resin. Here this is the anion exchange resin. These are made up of styrene divinyl benzene copolymer with phenyl formaldehyde or amine formaldehyde functional groups. Phenyl formaldehyde or amine formaldehyde functional. It is represented simple structure is here benzene on this CH2 and below here you can write CH2N. Okay, this is amine formaldehyde. Me2 plus OH minus. Me2 plus OH minus. This is a polymer. You can represent in the form of okay. Close the bracket and keep N. It is nothing but amine formaldehyde, phenyl formaldehyde, and amine formaldehyde. Phenyl formaldehyde or amine formaldehyde. Okay, this is a complex structure, but you can represent in the simple form. Okay, benzene on this CH2N. This is CH2N amine formaldehyde. Amine formaldehyde or here cation exchange resin is styrene divinyl benzene containing okay carboxylic functional group or SO3 sulfur oxide functional groups. Sulfur oxide functional groups. Now coming to the process, how this process takes place, how the using this resins, how we are going to remove the dissolved salts present in the water. Okay, here ion exchange process includes the exchange of cations and anions of the dissolved salts with H plus ion and OH minus ions respectively. Okay, here the process includes the exchange of cations and anions of dissolved salts with H plus ions and OH minus ions respectively. H plus ions and OH minus ions respectively. Coming to the process, cation exchange process. Cation exchange process. How this process is? First, what we are going to do means, okay, see this is a diagram. What here hard water contains, okay, this is a cation exchange resin. Okay, the first these are two chambers, two chambers. Okay, ion exchange purifier or softener we call, because we are going to remove the hardness causing salts present by using this ion exchange process. Hot water, okay, it contains the dissolved salts present in it. Okay, we are passing the hot water initially through the cation exchange resin. Cation exchange resin. The first chamber is cation exchange resin. Second chamber is anion exchange resin. Okay, it is the first chamber, that is anion exchange resin, and the second one is first is cation. Sorry, first is cation exchange resin. Second one is anion exchange resin. Here this round one indicates, okay, small indicates a gravel bed. Okay, it helps to filter more gravel bed. Okay, here we are going to this regenerate the resin. Initially we are passing this resin to this okay, cation exchange resin. Again we are going to regenerate it. Okay, regeneration of resin is there. We are going to regenerate the resin. Yeah, coming to the process, how the cation exchange takes place. Here, first what we are going to do means we are going to pass the hot water. Hot water is first passed through the cation. Okay, we have two chambers, already have shown. Two chambers are present. First, initially we are passing the hot water into the cation exchange resin chamber. Cation exchange resin column, or okay, cation exchange column. It contains cation exchange resin. Cation exchange column where all cations, okay, in the hot water. Hardness of water is due to presence of calcium and magnesium ions. Okay, here all the cations present in the hot water like calcium Ca+2 and Mg+2 are removed from it. Ca+2 or Mg+2 are removed from it, and equivalent amount of H+ ions are released. Equivalent amount of H+ ions are released from its column to the water. Okay, here first what we are going to do, we are passing the hot water into the cation exchange column. Okay, first chamber is this is called cation exchange. Okay, cation exchange column. Second one is anion exchange column. Cation exchange column and anion exchange column. Okay, it contains cation exchange column contains the cation exchange resin, and below that here gravel is there. It helps to filtrate the whatever the ions that are present in the uh, filtration, during the filtration process. Okay, here what we are going to do, here all the cations like calcium and magnesium ions are removed from it, and equivalent amount of H+ ions are released from its column to the water. Here we are passing the calcium chloride. Okay, hard water contains the calcium chloride and magnesium chloride. Okay, calcium chloride and magnesium chloride is passing through the cation exchange resin. Okay, RH, we are reacting with CaCl2. CaCl2. What it forms? R2Ca plus 2HCl. Okay, and second reaction, this is the first reaction, and the second reaction. Okay, again in the hot water it contains magnesium chloride. They are passing this in the cation exchange column, where cation exchange column contains the cation exchange resin. Okay, here what happens? It reacts with the resin and forms R2Mg plus 2HCl. R2Mg plus 2HCl. We have the reactions. Okay, again here this is the resin. It is reacting with the this salt like calcium sulfate. It forms R2Ca plus H2SO4. Okay, this is the acid. Okay, and RH2RH plus MgSO4, it forms R2Mg plus H2SO4. Okay, R2Mg plus MgSO4, H2SO4. Okay, here whatever the calcium and magnesium are retained by the cation exchanges as CaR or MgR. CaR, MgR, releasing H+ ions into the water. Releasing the H plus ions into the water. Thus, water coming out of the resin is highly acidic. Okay, whatever the water that is coming out from the resin is highly acidic because H plus ions are released by the cation exchange combines with anions of dissolved salts produce the acids. Okay, here whatever the H plus ions that are coming from the acid, okay, coming out of resin is highly acidic because it releases H plus ion. As acid is nothing but which donates H plus ions. H plus released by the cation exchange combines with anion of dissolved salt. Okay, whatever the anion that are present with the dissolved salts to produce the acid, produce the acid. Now, in the anion exchange resin, what happens? In the anion exchange resin, now whatever the
previous slide.
okay, yeah. Cation exchange resin, these are the reactions. RH plus COSO, Ca calcium sulfate mass, CaSO4, it forms R2Ca plus H2SO4. The byproduct is acid. Okay, RH plus RH is nothing but resin, reacts with the MgSO4. Okay, MgSO4 magnesium sulfate, it forms R2Mg plus H2SO4 acid. This calcium and magnesium ions are retained, means they are coming back by the cation exchanges as CaR or Mgr, and this is releasing the H plus ions into the water. Okay, it releases the H plus ions into the water. Because whatever these H plus ions that are releasing contains the high amount of H plus ions. That is, okay, water coming out of the resin is highly acidic because it is as it is releasing the H plus ions by the cation exchange resin combines with the anion of the dissolved salt produces the acid. Now coming to the anion exchange process. Anion. Okay, now we are passing into the okay, first column is now this is the same. It goes to the second column. Okay, here whatever we got the H plus ions, this H plus ions, this okay, here we got RH plus CaCl2, it forms R2 Ca plus HCl. Now this whatever Cl, HCl, that is byproduct. Now this byproduct is moved to the anion exchange resin. Okay, see, then the second column is anion exchange column. Then the water is passed through the anion exchange column. Okay, anion exchange column where anions like SO4 minus 2. Okay, sulfur, chlorine, etc. present in the water are removed, and equivalent amount of OH minus ions are released from this column to the water. Here, whatever the H plus released during the first column and reacts with OH minus ion, it forms H2O. Here in the first column, we got HCl as a byproduct. Okay, now this reacts with the anion exchange resin. It forms RCl plus the H2O. Okay, this water, whatever the water that is coming out from this, it is free from the all ions. Okay, it is free from the all ions, so it is called as a okay, deionized water or demineralized water. Who is that? Yeah. Now what we are doing in this sorry. Okay. Now in the whatever the water that is coming from the first column, that is cation exchange resin. Okay, we are passing through the anion exchange resin. Okay, the cation exchange resin, it contains the HCl and H2SO4. Okay, it is containing the HCl and H2SO4. Okay, this is now passed through the anion exchange column where anions like sulfur and chlorines are present in the water are removed and equivalent amount of OH minus ions are released from the column to the water. Okay, here H plus ions are combines with the OH ions and it forms H2O. Okay, H2O. Here ROH is nothing but anion exchange resin combines with the HCl, the byproduct we got from the combines with the HCl to form RCl plus H2O, RCl plus H2O. Whatever the water that is coming here is okay. It is a pure water. It is does not contain any ions. Like it is free from the all minerals. Okay, so it is nothing but demineralized water or deionized water. Demineralized water or deionized water. Okay, this is pure form of water. The water coming out from the exchanger is free from the all ions known as deionized water or demineralized water. Water coming out from the exchanger is free from the all ions present in it. So it is called as deionized water or demineralized water. Okay, or ion exchange process. In the exam, they may ask, okay, what is deionized process? Deionized process or demineralized process or ion exchange process. All these names are similar. The ion exchange process. Ion exchange process. Okay. Okay. This is how we are going to pass the hot water. Initially, we are passing the hot water through the cation exchange column. Cation exchange column. Here, what happens? Cation exchange column contains the cation exchange resin. Cation exchange resin is RH plus. RH plus reacts with calcium chloride, CaCl2. Okay, it forms what it forms. Okay, R2Ca plus it byproduct it gives us what R2Ca plus HCl. Like that, whatever the reactions we have now, R2Ca plus HCl. Here HCl is okay. Now this HCl is passed through the this whatever the water that is containing, it is passing through the second chamber. Okay, it is passing through the second chamber through this from the pump to the this column. From here in the second column it contains what anion exchange column, where anion exchange column is reacts with here anion exchange column contains anion exchange resin. Here ROH reacts with HCl, it form RCl plus H2O. Okay, RCl plus H2O. Whatever the water that is coming from this is soft water. Okay, we are passing the hard water from here. We are getting the soft water. That is nothing but deionized water. Deionized water or demineralized water. Demineralized water. Demineralized water. Okay, here in this column, now we need to regenerate this process now. We are going to, because these exchangers are very costly, by passing the acid solution. Okay, we are going to regenerate the cation exchange resin, and by passing the alkaline solution, we can regenerate the uh, anion exchange resin. Cation exchange resin we are going to regenerate by passing the acid solution. Okay, acid solution regeneration of resin. Here see in the diagram it is shown acid solution for regeneration of resin. Okay, by passing the acid, we are going to regenerate the cation exchange resin by passing through the alkaline solution, OH minus solution for the regeneration of resin. Okay, here see we are passing the hot water which contains chloride sulfates. Okay, okay, whatever we are passing here, and the water that is coming out from this here is from the second anion exchange column is soft water, that is deionized water or demineralized water. We call it as ion exchange process. Ion exchange process. Now, this is the regeneration of resin. How we are going to regenerate this cation exchange resin and anion exchange resin. Cation exchange resin and anion exchange resin. Coming to the regeneration of Phleginma, after the deionization of certain amount of raw water, deionization of certain amount of raw water, okay, the cation and anion exchanges are exhausted. Means it will be it loses its capacity. Okay, this anion and cation exchange resins are exhausted. Okay, it loses its filtration process, it loses its capacity to filtrate these cations and anions present in the hot water. Now, what we need to do, we need to regenerate. Okay, regeneration of cation exchange is carried out by passing the dilute HCl. Okay, by passing the dilute HCl and dilute H2SO4 solution into the cation exchange bed. Cation exchange bed. Okay, here H plus ions of the acid are exchanged with cations like Ca plus and Mg plus present in the cation exchanger. Cation exchanger. It forms just reverse of the whatever we got the in the process. During the process, whatever we got the reactants here, the reactants are the products and the products are the reactants. Just we need to reverse these reactions. Okay, here cation exchange resin RH plus reacts with CaCl2 present in the hot water. It forms R2Ca plus HCl. R2Ca plus HCl and RH plus MgCl2, it forms R2Mg plus HCl. R2Mg plus same, whatever we got it now, we are going to just reverse it. After the deionization of certain amount of raw water, this cation and anion exchanges are exhausted. So we need to regenerate this cation and anion exchanges by passing through the dilute HCl and H2SO4 solution into the cation exchange resin. See in the picture. Okay, the picture also it is shown. Okay, we are passing the acid solution. Okay, that is like acid is nothing but dilute HCl or H2SO4. We are passing this solution into the cation exchange resin. Okay, this is a cation. Yeah, Agarwal. Cation exchange resin. Okay, by using we are going to it reacts with. Okay, it reacts with the calcium and magnesium ions present in the cation exchanger. Cation exchanger. Here H plus ions of the acid are exchanged with cations and anions like Ca plus 2 and Mg plus 2 present in the cation exchanger. Here R2Ca we got in the process, during the process. It reacts with the HCl acid, it forms okay RH. This is nothing but resin. This is nothing but regeneration of resin. Okay, what we got the RH from this. Okay, RH plus CaCl2. RH plus CaCl2. Just reverse one. During the process, what we have done? 2RH reacts with CaCl2. We got R2Ca plus HCl. Just we are reversing here. Regeneration of cation exchanger is carried out by passing the dilute HCl and H2SO4. Yeah. Okay. H plus ions of the acid are exchanged with cations. Cations like Ca plus 2, Mg plus 2 present in the cation exchanger. R2Ca plus 2HCl, it forms 2RH plus CaCl2. Okay, now here the washings containing CaCl2 and MgSO4. Okay, whatever this we got now, CaCl2 and MgSO4, etc. were passed to the sink. Okay, this byproduct we got now, byproduct during the regeneration. Okay, we are using this as a resin again. We are using RH. Okay, we got the resin, but byproduct is CaCl2. CaCl2, if you react with Mg, R2Mg plus H2HCl, you will get RH plus MgCl2, or Mg, if you use H2SO4, you will get the MgSO4. These are byproducts. Okay, washings containing CaCl2 and MgSO4, etc. are passed to the sink or drain. Okay, we are passing through this into the sink or drain. This is a byproduct. There is no use of this CaCl2 and MgCl2, and we are passing into the sink this CaCl2 and MgCl2 into the sink. Yeah, here it is given the wastage. This here wastage to the sink. Okay, whatever the wastage that is produced now, it is passes through the sink. For the wastage, we are going to pass through this pipe. This is the ion exchange process. Ion exchange process, cation exchange resin and anion exchange resin. What are its advantages and disadvantages of this process?